So final preparations. We're going to perform a few additional tasks, create a set of directories in LFS which will install temporary tools, create an unprivileged user and an appropriate build environment for that user, explain what SBUs are and measure how long, which is used to measure how long it takes to build packages, and some information about package test suites. So we're going to create a limited layout, so just create some initial directories for the new Linux from scratch system. And once again, before we carry on, we can just ensure that we've still got LFS set and the umask is set. They're both correct, so we can carry on putting these commands in. And you'll notice that I'll be putting commands in one at a time, and that's to ensure that we get to read the output if there is any output, and also to ensure that if there was an error that we know what commands produce the error. There's a possibility if you put multiple commands in at a time that the error might not appear next to the command that it's associated with, so it could be a bit misleading. So now let's create a directory to put the temporary tools in. There's a message there about not using a user lib64 directory, and the reasons why that is. Adding the LFS user, so first of all we'll create a group for it, LFS added, and then we create the actual user LFS. Then we create a password for it and type a password that's easily memorable. Oops, yeah, you can tell what password I use there. And change the ownership of all the directories we've just created to LFS so that it's got access to them. And in the case of a 64-bit machine, we do something else. Right. Oh yes, that message previously was about there's no user lib64 directory, so this is just the lib64 directly off what will be the root. These commands where it's got a case, run them in anyway whether you're on 32-bit or 64-bit, because they've coded them such that the command will operate as per the architecture you're on. So for example, if you're on 32-bit and you ran that command, it wouldn't actually do anything because it's looking for 64-bit. So it's safe to run the command in if you're unsure, irrespective of what architecture you're on. It does say some host systems the su command does not complete properly, and you have to type the fg command to fix the issue. That hasn't happened to me for a while, but I think that's because it used to happen to me on Endeavour OS, and I haven't used that for a while now as a host. But if it does do that, then that's the answer to it. So now we're going to become the LFS user. And there we are, we've got a green prompt to show that we're a non-privileged user. So now we're going to set up the environment. So create a bash profile with some settings there, and then a bash RC with some more settings which will be used by the build environment. It explains all that there. As I said before, it sets the umask up for this user automatically and LFS, so I will check them, but there's no real point because it's in there by default. Every time we log in, they'll be set. There's an important information here about undocumented instantiation of etc bash rc to the initialization of bash, and it could cause problems basically if you read that. It says to run this command here, and if you have got one of these distributions, you'll see something print up on the screen because it basically hides this file away from the system. This has got to be done as root, so let's come out, rerun that, And you see nothing printed up for that, so you can see that Gen 2 doesn't do this, but there are obviously other distributions that do. So once you've done that, go back into LFS. Oh right, okay, that's because the paste is double pasted for some reason. It does happen with this mouse sometimes. I have to be careful with that. So I'm going to do that again, and I'll log out and log back in again to make sure that error's gone. Yes, it has now. So then it talks about using multiple cores. Explains there about a Core i9-13900K, how the cores are laid out, which ends up in having 32 cores available, and adding this to this environment variable, to allow make to use 32 cores. And there's a bit of script here to add this in to the bash RC, and it automatically pulls how many cores you've got available, so don't need to do anything else. So now if I log out and log back in again to make sure that's all working, and I do echo $make flags, you'll see that says -J4, which is correct because there's 4 cores available. And in fact it says to source the bash profile to update the environment with that make flag, so it's pointless now for me because I've just logged out, but you can do that without logging out. About SBUs, always been a bit of a contention for me, that they're not particularly accurate. They only give you some sort of guidance. There is some information here about, they're suggesting that the power profiles may be affecting the estimates of the SPU. The fact that CPUs can throttle their speed depending on the power profile in use. So that may be a possible reason. But to be quite honest, I think there's far too many variables to put it down to one thing specifically. I'm sure this does affect the final figures, but there's other things such as, well, the number of cores, the types of cores now, whether it's a performance core or an economy core. You might run a build and certain intensive jobs might end up on a performance core on one run, but some of them might actually end up on an economy core on another run. So that could potentially affect the SPU result. There's things like caches, the number of caches, whether the caches are shared between instructions and data and so on. There's the amount of memory you've got, there's the speed of the memory, how the memory's paged, whether it's got 1, 2, 4 channels. There's so many factors that it's impossible to pin it down to one particular thing. I guess them putting this in the book does narrow it down a little bit, but I'll put money down to the fact that it still will leave the SPUs being potentially wildly out in some cases. I maintain that you're probably looking at SBUs being classified in 3 categories. Those that take a matter of seconds really on a fast machine, maybe up to a minute, those that take several minutes, and those that take multiple minutes, 10 minutes, an hour or so, or more. So basically, is it a quick, medium or a long build? I think is probably the best way of looking at it. And the reason why I say that is because when you're sitting there typing it in, you want to know, are you going to type in a command or build a package and it's going to build virtually instantly? Or are you going to build a package and it's going to take a few minutes to build, i.e. enough time to nip out and get a cup of tea, for example? Or is it going to be a package that's going to take half an hour to build? So that would be, for example, enough time to pop out and make yourself a sandwich and eat it and then come back. And that to me is a more practical way, because it gives you an idea of, do I hang around waiting for this or don't I hang around? Do I come back to find that it only took a few seconds and I've been away for an hour, or am I sitting here waiting for this to finish quickly and it's actually going to take an hour? So I think that might be a more humanist or human orientated way of looking at it, rather than a mathematical way of looking at it, which it's accurate, but accurate in certain instances, certain situations which can't be replicated easily because of the way computers multi-process and just the different configurations that people have, which would affect how how long the build takes. I've even just thought of another thing I've noticed in the past, that most packages, although they may compile on multiple cores, a lot of the time they're only actually executing on one core. So again, that would affect it. So you might have a package that, say, spawns 100 threads, and on a 4-core, it would obviously have to multiply that 25 times, say, for example, if they all took the same amount of work. And on a 50-core, for example, it would only spawn those, each thread of those available threads to work on, it would use 2 threads each. But it's not working on 100 threads constantly. Each individual thread might take a different amount of time to finish. So you might get one core that works on half a dozen threads because they're short, or half a dozen jobs, and another core that only does one job throughout the whole compile. And that's quite apart from the fact, as I said before, that with today's hybrid processors, some cores are more efficient than others in terms of processing power. So yeah, it's a extremely complicated thing to be able to say, here's an SBU, and this will give you an idea. Just take it as being a guide, and not a scientific method of predicting accurately how long packages will take to build. So about test suites. Test suites aren't normally run initially, they're only really run in Chapter 8 when we're doing the final build. I think I did run test suites once in the early part of the build, in the temporary part, many versions ago, and yeah, it was a bit pointless, I think, because there's too many factors that are based around the host system. It's an incomplete system anyway in the temporary tools part, so it's not worth doing. It's definitely worth doing in the final Chapter 8 because you're building a system that you hope to have working. You won't know that it's a good system unless you've run the tests to prove to you that the tests are passed, and therefore indicating that what you've built is good and good to be used. Another thing is, what's to say that you build one of the earlier packages, don't know that it's not built correctly, but it's used several times later on to build other packages, and you get problems with those packages. You won't know why, because you weren't aware that earlier package didn't build correctly. So it's definitely, it's not mandatory, but I'd say it's nearly mandatory, I'd say, to do it, especially if you've never done Linux from scratch before. If you're an old hand at Linux from scratch, I'd still advise to do it, but you're probably a bit more aware of the likely pitfalls, and you could probably get away without running the test suites. But yeah, for a new user to Linux from scratch, I'd say definitely run them.